I've mentioned to you before that in mathematics, one of the things that we frequently will do is we will try to come up with an equation to model something. Like we've talked about, like how the CDC would make an equation that talks about the model of how the spread of the coronavirus is happening, right? Or we're coming up with some kind of a model to determine when, for example, the Social Security Administration will flat out run out of money and not be able to pay the people that have paid into it. Those are kind of significant things to do. So they come up with these equations, and I kind of mentioned this to you guys at one point in time, that sometimes when you go to make those equations, one equation isn't good enough. Would the coronavirus equation change if they came up with a vaccine? So the current model that they're basing all of their estimates and all the needs and everything they're doing, would it totally change if you had that? It would. So what I'm going to do is I'm going to try to model a little story here to kind of show you what I'm talking about through a different lens. So let's imagine, everybody, that I wanted to do a little side hustle, and I wanted to make a business out of my garage. So I need somebody to say, what am I going to make and I'm going to sell online out of my garage? Pick something. Wrenches? Wow, okay. We are going to start supplying California and the rest of the world with wrenches, and I'm going to set this whole thing up. That's a fantastic example. Okay, so let's just say that I have not made any wrenches yet, and I want to model what happened in my business. Well, to make wrenches, the first thing I need to do is I need to get the ability to forge steel. I also need to get a steel press. I need to get a bunch of grinders and a bunch of equipment that's going to put all that stuff together. I have a lot of debt now. You with me? I have an equation that says, okay, I'm setting myself up to make a certain number of wrenches. Ooh, and I got a lot of debt. And so now I go out online and I start making my wrenches. And now people are buying my wrenches. But what would happen? Would the equation be the same if I was able to sell 200 wrenches as it would be if I sold 4,000 wrenches? What would change if I went from, say, making 200 of them to 4,000 of them? What's that? The maths are killing me. Part of the issue is, am I going to potentially outgrow my garage? And I can't have a forge that's big enough in my garage. I might need a bigger press, right? I might need something much more substantial. What else could change my equation in addition to maybe just needing more space for equipment? What else might I need if I have lots of orders? Helpers, employees. Would those employees change my equation? And in fact, if my business gets too big, all of a sudden now I have to deal with OSHA, which is the Occupational Safety and Hazard Administration, that's going to come in and say, do you have the right breathing equipment and the right stuff to make sure that your workers are safe? See, every single time I do something, my equation changes, doesn't it? So the idea of mathematical modeling is a fantastic idea, but quite frequently, it's insufficient to come up with one equation that tells the entire story, okay? So this is what we are going to try to do today, is we're going to look at how do we tell the story when one single solitary equation is insufficient. And so what we're going to call this is a piecewise defined function. Now I want to bring something up right off the top. It is called a piecewise defined function. So if something is a function, for any input, how many outputs must there be? One, which means if I ask a question, you can't say this or this. It has to be one and only one answer. So here's my first piecewise defined function. Now, I know people sometimes look at math as somewhat contrived, and it's really because the story that I was telling about wrenches would be a very complicated set of equations, very complicated. So I'm going to simplify it. And I'm going to give you a simple little story like this. I've got some strange function g that looks like a parabola. You guys see that? Isn't x squared a parabola? But for some reason, the model ceases to be the correct model once I reach 0. From x equals 0 up to about x is 3, the right model is just that it is no longer a parabola. What is g of x equals x supposed to be the graph of? That's a simple line. And then maybe we'll go one step further, and let's just say that it is the number, I'm going to go with the number 4 for any value of x that is above 3. So I messed with it just a little teeny bit. Okay, so I have this model that as my business grows, I keep changing what equation does that. So back in Algebra 2, what happened if your teacher asked you to do something like that? What does g of -5 literally say to go do? It says go plug that thing in. But I've got 3 things that I could plug in. So is it 25? Is it -5? Or is it 4? Because if it's a function, how many answers are valid? 1. So which place should I plug this in? Well, look at your directions. What x did I tell you to plug in? Is -5 below 0? Is it between 0 and 3? Or is it above 3? Oh, it's right here, isn't it? So what does that make the answer? It's going to be 25. It says, oh, plug it into here. This is the place where that is valid. What about if I asked you for g of, let's say, 17? So is 17 in the first region below 0? Is it in the second region between 0 and 3, or is it above 3? It's above 3, so it's right here. So g of anything above 3, what does this say the answer is? It's 4. Oh, cool. How about g of 1.6? Which region should I be in? I should be in the middle region, right? And what does it say g of x is? Whatever x is, which is 1.6. So your turn to answer a couple. You are going to find out what is g of the square root of 3. What is g of 5 pi? That's so mean. Sorry. And what is g of -2/3? I did the easy ones, so I want you to do the hard ones. Okay, so which region? Top, middle, or bottom? Where would root 3 be? Middle. So what's the answer in the middle if I plug in root 3? It's root 3. Done. Where's 5 pi? 5 pi is that? 5 pi is a little bigger than 15, isn't it? So that's which region? The bottom one. So what does it say the answer should be every time? No, okay, we're done. And how about -2/3? Which region should I use that time? The top one. So if I plug in the top one, what happens if I square -2/3? I got 4/9. I'm done. That's it. See? Pretty simple little idea. Now, as far as what the graph looks like, this is kind of strange. You guys know what a parabola looks like, right? But this is a strange parabola. It looks about like this. But how much of the parabola did I graph? Half of it, because what somebody did is they took the parabola and they cut it off at 0. Oh, so I have half of a parabola because they told me to stop. And then from here to here, it's supposed to make a line. Now let me ask you a question. Should I fill in that 3, yes or no? Why? Because it says equal to. Now there's something that's kind of strange that happens this time that happens sometimes and not others. But as I see, what does x squared get close to if I get close to 0? Doesn't it get close to 0? But what does this one also get close to? 0. So from the left side, it was a closed point, but in the right side, it was an open point, but they were on top of each other. Is that okay? Yeah, it's still a function because it was valid on top. And then once I reach the number 3, it becomes 4. Now, why did I make an open circle at 3? Because it said, don't touch it, right? So this is called a piecewise defined function. So you can see the parabola, the nice little uphill line, and then the horizontal line. So similar concept, h of x is going to be a function which is the absolute value of x plus 3 for values of x that are below 0. It is the number, let's say 4, for values of x between 0 and, let's say 2. And I'm going to go with the square root of x minus 2 for values of x. Oh, I'm going to actually just go greater than 2. So there's something kind of strange that I did just to mess with you just a little teeny bit. Do you guys remember what an absolute value looks like? It should be a v. But what did somebody do to the v? They kind of broke it off, right? They didn't let me see the entire v. They broke the story off a little bit. So let's see what you guys know. What is h of 11? What is h of negative 14? And what is h of, 1.714? On your next test, I literally have some questions like this where I just have a piecewise defined function and I say, hey, can you evaluate it? All right. 11, which one would I use? The bottom one. What happens if you plug in 11 into the bottom one? 11 minus 2 is 9, root 9 is 3, we're done. Where do you like negative 14? Down here? The bottom one? No, negative 14 should be way below 0. So what happens if you plug in negative 14 to that one? Negative 14 and 3 is negative 11, and the absolute value of that should be, 11. That's pretty easy. And how about this one? 1.714, where's that? That's in the middle. And what does it say should happen? Always in the middle. It was just 4, no matter what. So as far as a graph goes, this graph has an absolute value that looks like this. Now again, if you're not very good at graphing absolute values, you could plot in a bunch of points and do that. So notice it bottomed out here at negative 3, 0, because that's an absolute value bottoms out at 0, doesn't it? So can I let it reach 0? Does the absolute value, does this v actually reach 0? It gets really, really close to 0, so I need to put an open circle to say, hey, you can get close to that, but don't you touch it. And then from 0 to 2, what's the height supposed to be? It's supposed to be 4, just like that previous question, so it's going to come along like this. From 0 to 2, it's supposed to be a horizontal line, but should I have solid dots or closed dots? On the left, what should it be? Solid left. How about on the right? That should be open. And this is kind of strange, and I know that not all of you probably feel very comfortable with this, but then square roots look like that. Strange. Strange looking little graph. And by the way, what's the domain of this thing? Oh, that's weird. Is there any value that I cannot plug in according to this graph? Hiram saw it. What is it? 2. See, I can plug in all sorts of stuff, but this doesn't let me touch, that doesn't let me touch 2 either. So all of a sudden, this domain is everything except for 2. I can ask any question I want, but 2 seems to be bad. You guys cool? All right, last one. Last one, and this is going to be j of x. J of x, strange little sucker. J of x is going to be x cubed for values of x below 1. It's going to be x minus 1 squared for values between 1 and, oh, let's go with 3. And then, this is a new one for you guys. The greatest integer of x for values of x greater than or equal to 3. This is my way of actually kind of getting some new thing for you. So the greatest integer function is what this is called right here. The greatest integer is, I would liken it to a really bad boss. If you work for 3.8 hours, would you be happy if your boss said, then I'll pay you for 3? And if you work for 3.9 hours, I'll still pay you for 3. When will I go ahead and give you that 4th hour for your efforts? Literally the moment the clock strikes 4. The greatest integer function is this crazy thing that always rounds down until you get to that next value, okay? So what is the greatest integer of 6.1? 6. The greatest integer of 7.9 is 7. Sadly, the greatest integer of negative 4.2 is negative 5. What did I say it always does? It rounds down, and actually negative 5 is below negative 4. Isn't that weird? So on the high side, it just truncates, but on the low side, it actually skips down. So this problem has this nice little S curve, which I think you're familiar with, right? I think you guys know what x cubed looks like. Why did I put an open circle at 1? It says you can't have it. Then from 1 to 3, we have this nice little parabola looking thing. Kind of looks like this. And I think I made a mistake because I should have a solid dot at the 1. What should I have at the 3? That should be open. Oh, and then it starts doing this. So I don't know if you kind of catch that every single time it rounds all of those numbers down. So 3 remains 3 until I reach literally the number 4. So 4.1, 4.2, 4.79, all of those become 4 until I reach the number 5, and then it jumps up. So what would be j of negative 3? Which equation would I use? I think negative 3 is in this top region, isn't it? So that would be negative 27. How about j of 73.8? Where is 73.8? Top, middle, or bottom? Definitely bottom. And what did I say the greatest integer function does? Is it rounds stupidly just to the next number down. And I hope that's fairly straightforward. Of course, I guess I could give you J of 3/2. Which one would 3/2 be? That's the middle. What is 3/2 minus 1? That's 1/2. But then it says 1/2 squared, so I guess it would just be 1/4. So that's called a piecewise defined function. And so what you guys are going to work on today is you're going to work out of the homework, which is set 1.3b. You're just going to be playing with some of those numbers. So please understand that there's two things that are happening. Yesterday, very briefly, I talked to you about the 12 major functions. Each of these things that I have are part of those 12 major functions that I want you to recognize. But we're adding the idea of these piecewise defined functions. The rest of the period is work time. If it would be helpful to you, I can pull up the specific assignment list on that so you know exactly what, but you know the textbook is in Google Classroom and the assignment is there too. So I'm going to go ahead and hit stop share on that and